Hello, everybody. This is Nick, and welcome back to my Valentine's Day special video. So, it's not going to be our usual physics or math video, it's going to be a bit special. So, today we're going to talk about you. So, I don't know what you want to be, but let's assume you want to be something which is pretty, ambitious, like, whoa, bro, I'm going to do this, It's like this thing, like a footballer, right? Or an engineer or something like that. Every day might be very boring. It's like, how long do I have to do this for? And it's like, you just want to get out of there. And I don't blame you. You can feel really lost sometimes. And you can worry about the future. Will my future be like this? Will I be working some boring 9 to 5? Well, I'm here to tell you that it'll all come together, okay? It'll be okay. I have no script, so bear with me, okay? I think that if you truly enjoy something, you'll be able to find happiness in that. So don't be sad, don't worry, it'll work out. Sorry for the inconsistency. I've been very sleepy for the last few days, and yeah. Sometimes you've got to let your mind wander. See, I for one, I really like physics. Like, wow, it's a sunny day when physics is around. So find something you like and do it. It doesn't even need to be something that other people appreciate, as long as you appreciate it. That'll fix you, it'll tighten you up. And yeah, you'll have sunny days in the future. And today, you might be alone. I'm alone. I'm sitting in my room. And the only logical thing to do is physics. So let's get started. Don't worry, we won't do much today because, you can go and have chocolates or whatever you do on Valentine's Day. But we'll do a little bit, okay? So, I drew a character. All these things are hand-drawn by me, by the way, so you gotta I think you guys should clap. Anyway, let's start. So, it's a small bit, okay? A liquid of density rho fills a container to a depth h as shown in figure 2.1. H, how do you pronounce this stuff? The base of the container has an area A. That's this, alright? Now, derive from the definitions of pressure and density the equation this. So what this equation tells you is pressure is equal to the density into the gravitation constant into the height, right? So G is acceleration of free fall. Cool. So they want us to derive this from the equations of pressure and density, right? So what is pressure? Pressure is equal to force by area. Density is equal to mass by volume. We can start with this. We can prove that this using this is equal to this. It's the same thing. That's what we're trying to tell. So what's our root? First, we need to look for a way to relate this. Can we express volume as something else? We can. Density is equal to mass into area into height. Think about it. If you have a cylinder with this much volume, that's the same thing as saying the area of the cross section into the height, right? It's like many of them stacked atop each other. Both of them give you volume. So now we have this as the definition of rho, density. Step 2. Now, density is equal to now we multiply h on both sides. So we can say that density, sorry, wrong symbol. You're supposed to use the symbol rho for density, okay? So rho into height gives you m into A into H into H. So what we're doing essentially is distributing height on both sides. The equation will not change because we are making the same change on the left hand side as well as the right hand side. So on this side, you can see that the height in the denominator and the height in the numerator get cancelled out. So we can say that density into height is equal to, very good, mass by area. We're getting there. You see how we have this and we have this? We just need to fit this over here. So in our fifth step, let's try multiplying the acceleration of free fall constant on both sides. So density into height into g is equal to mg by a. Whoa, wait a minute. Force is equal to mg, mass into the constant, and that's the definition of pressure. So I'm sorry if my route is a bit messy, but I hope you get the general idea. You will need to do this for a lot of equations. This is just one such example where you'll need to kind of expand, like express volume as area into height, and if you can make these connections, you'll be fine. Okay, next, a small solid sphere with constant velocity. Okay, when you see something like this, I think you should highlight it because it's important. Falls with constant velocity through the liquid. Whenever we're talking about forces and constant velocity is mentioned, you should be like, whoa, put on your thinking cap because this is important. First, state the names of the three forces acting on the sphere. So visualize it, right? Sphere falls through the liquid. Obviously the first thing which is making it fall is gravity, right? So you can say it's weight. That's the based off of gravity, so we write weight. You don't say gravity. Next, there's also an upthrust, right? In the water there is an upthrust, so we can say upthrust. The upthrust always acts upward in the water. And then anything moving in a fluid, right, be it water, be it air, that is drag. What is drag? Drag is a force that opposes the movement. So for example, if this plane is moving here, drag would move exactly opposite the drag force. And for the plane to be able to move forward, it would need to overcome that drag force or equal that drag force and attain a constant velocity. But for it to accelerate, it would need to overcome this drag force. Anyway, that is accelerate forward. So weight, upthrust, and then we can say drag or viscous force, right? So these are the three forces acting on the sphere. Now write a word equation that relates the magnitudes of these three forces. That's interesting. Now that's where constant velocity comes to play. When velocity is constant, the net force is zero. That doesn't mean there's no force acting on it. That means the net of those forces, which means if this is force x and this is force y, x minus y should equal 0. Okay? So for this to apply, right, we consider the direction of both of the three forces. So weight is acting downwards, upthrust is always acting upwards, and drag is opposing the motion. The ball is moving downward, right? It falls. So the drag would act upward. So we have these two and we have these two. And for both of them to balance out, weight should be equal to the upthrust plus the drag. I hope that made sense, and I wish you a good night. I hope you enjoyed this video as much as I did, and I'll see you in the next one.